we would like to be able to use trigonometry, these ratios here, to figure out an unknown angle in a triangle. That would be handy, for like carpentry, to figure out the angle of a roof. And we want to be able to do that to figure out this unknown angle when we know two other sides and we know that it's right angled. To do this, we'll first need to learn a little bit about opposites. So this is just to get your head around something in trigonometry, and opposites in trigonometry, that can help us to find the angle. Because this is kind of the opposite problem to the one we've done before, where we're finding a side. We're not finding a side now. We're given the sides. We want to find the angle. So let's learn a little bit about opposites to help us with that. Suppose I have some operation, and if the operation is adding, then the opposite is subtracting. If I know that x plus 5 equals 9, well then I can do the opposite. X equals 9, take 5. The add 5 has turned into subtract 5. It's the opposite. If I have multiplying, so for example I've got 5 times x equals 10, then the opposite of multiplying is dividing. So if I know that 5 times x is 10, the opposite of multiplying by 5 is dividing by 5. So it will turn into a divide by 5 on the other side. Suppose I have squaring, like x squared equals 9. If I'm given an equation like that, and so I want to find x, I can do the opposite of squaring. And the opposite of squaring a number is the square root. So x would be the square root of 9. Technically speaking, there are actually two solutions here. Technically, it should be plus or minus, but that's a detail that does not matter for today. What about if I've got sine? If I know that the sine of some angle is 0.5, what is the opposite of sine? Well, I haven't taught you that yet, but I'm going to tell you we have a name for it. If you know what the sine of an angle is, and you know that the answer is, let's say, 0.5, you can figure out that unknown angle by doing the inverse sine. In other words, we write it like this. If you know that sine of an angle is 0.5, for example, then the angle is the inverse sine of 0.5. I've got a little race here that you can do, which is who can find an angle such that sine of that angle equals 0.5. You could spend ages on trial and error trying different angles, trying to get something close to 0.5, or you can use this inverse sine of 0.5. So to find the angle, we're going to use that now. We'll do the similar sort of thing as before, where we need to figure out which formula to use. I want to figure out this angle here, so that's the angle that I'm thinking about. I've got this side here, the 5 centimeters. Is that opposite, adjacent, hypotenuse? The 5 centimeters is opposite, because it is the one side that does not touch the angle. It's far away from the angle. And what about this 8 centimeters? Well, is 8 centimeters, is this opposite, adjacent, or hypotenuse? It is adjacent because it's next to the angle. Of course, there is one other side that's next to the angle, which is this one up here, but this one has a special name, and this one is called the hypotenuse. Cool. All right. So, we want a formula that links this length and this length and this angle, so it will have opposite and adjacent. Which formula has opposite and adjacent? It is tan theta. So tan of this angle is 5 over 8. Let's write that formula down. Tan theta equals opposite over adjacent. We can't replace theta with an angle because we don't know what the angle is yet. That's our unknown. But the opposite, I can replace opposite with 5. And adjacent, ADJ, adjacent is 8. So therefore, tan of the angle is 5 over 8. Therefore, remember the opposite? The opposite of tan theta is inverse tan theta. So whenever you have something that says tan of an angle, some unknown angle, and you want to figure out that angle, the tan disappears and turns into inverse tan. Do you notice that the tan is gone from this side here? It's turned into inverse tan. In other words, tan with a little -1 of this, whatever that side was. So that side was 5/8. That goes inside the brackets here. Because the tan is gone, the only thing that's left is theta here. We'll see that again in this one for a different trig function, just to get a bit more practice on how the tan turns into inverse tan on the other side. Okay, so in other words, we can just put this whole thing in our calculator. You may need to press on your calculator the shift button or the second function button. Normally it's a yellow button in the top left-hand corner, and then press tan, and then do 5/8. So if you put that in your calculator, you will get something like 32 degrees. Maybe just check that that works for you to make sure that your calculator is set to the right mode and everything. Whoa. Let's just hit pause just for a second there. You might be wondering how to put this in your calculator. Just to help you out, if you don't have a calculator in front of you, I'll show something that can help. Just search for calculator on Google, and then we have a calculator. Neat. Google search engine includes a calculator built in, very convenient. To type inverse tan of 5/8, first of all, check that you are on degrees. Hit that degree button. If it's not in degrees, you will get the wrong answer. And then we want inverse tan. So click on inverse, then click on tan. Inverse tan is also called arctan, or the arctangent. But I guess you don't really need to know that. So we've got inverse tan. To do the 5/8, this is the same as 5 divided by 8. 5 divide 8, end bracket, and then hit the equals. 32.005, blah, 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 blah. I've decided to give my answer to 2 decimal places. So I look at the next digit, which is a 5. That means round up. So instead of 00, it turns into 01. Okay, let's go back to the trigonometry. So if you put that in your calculator, you will get something like 32 degrees. Maybe just check that that works for you to make sure that your calculator is set to the right mode and everything. And just for a little sanity check, does this angle look like 30 degrees? Yeah, I guess so, because this here, that would be a 90-degree angle, that L shape, and I suppose it's about a third of a 90-degree angle, so it seems reasonable. And in fact, we have found this missing angle. Cool. Let's try another one for a little bit more practice. Find the angle theta. Again, I have 2 sides that I know. I want to figure out a missing angle. This side here is the one side that does not touch the right angle. And it's also the longest side. So is this adjacent, opposite, or hypotenuse? Well, it is hypotenuse. I gave it away a little bit earlier, didn't I? And the other side that we know is this one here is a side that we know. This side is 10 centimeters. Is this adjacent, opposite, or hypotenuse? It's adjacent because it's next to the angle. Do you notice that it touches the angle there? If this is the angle, then it touches that angle. Okay, so we're looking for a formula out of these 3 that can link these 2 things we know and the angle that we don't know. So it should have hypotenuse and adjacent in it. Which of these 3 formulas has hypotenuse and adjacent? It's this middle one. Cosine theta is adjacent over hypotenuse. So that is what we write down. Okay, cool. Let's start replacing things. Can't replace theta. I don't know what the angle is. But I do know what the adjacent side is. It's 10 centimeters. So I'll replace that with 10. And the bottom, it says hypotenuse. The hypotenuse is 14 centimeters. Cool. So now I have an equation. Now, do you notice I have cosine of theta? The cosine will go to the other side and turn into inverse cosine. It'll turn into cosine -1. On this side, the cosine will disappear from this side and turn into the opposite, cosine -1, inverse cosine, on the other side. That means the only thing that's remaining on the left-hand side is this theta here. The equals we copy down, and this we copy down. The reason I put it in brackets is just to show that we are taking the inverse cosine of this whole fraction here. Okay, and sure enough, if you put this on your calculator, then hopefully you should get 44 degrees. And, I think this is pretty close to 45 degrees. Let's just have a little sanity check. If this, Mr. Neri, learn how to draw a straight line. If this is a right angle, 90 degrees, then yeah, I suppose this angle is half of 90 degrees. That seems reasonable. Good. So my answer seems sensible. So this is how you can find the angle if you know it's a right angle triangle and you know two lengths. I might also show you why you might do this. Suppose you're a carpenter and you're building a staircase. In most countries, there are laws on that angle that a staircase can be. It can't be too steep because then it's dangerous. The handrail needs to be a certain angle, all sorts of things. So if you want to build a staircase and you know how tall the second story is, how high up the second story is, and you know how much room you have on the ground to play with horizontally, maybe the room is only 5 meters long, and you want to figure out, can I legally build a staircase in just this tiny space? Well, this is just the same problem. It's trying to figure out the angle if you know two sides. So this is just one reason, other than, game development and a host of other things, where you might need to find an angle, or might want to find an angle just like this. All right, I will see you guys next time. Good luck. Let me know if you need a hand. Bye, everyone.